example 2, we have j of x. Now we're translating it 4 units left and 5 units down. We want to write the equation again and state the domain range. So I'm going to look at these 3 points. They seem like important points. I'm going to take them, move them 4 units to the left. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. 1, 2, 3, 4. And draw where those points are. And then now when you draw a graph from a textbook that goes on forever, you need to put arrowheads on it. The textbook, when their graph ends at the edge of the graph, they didn't put arrowheads on, but there should be. So they basically cut the graph off, and if it cuts off at the edge of the graph, it's assuming it went on forever. So there we have our blue graph. It says write the equation of the image graph in terms of the function j. So that means I need to have j of something on the right-hand side. I've moved 4 to the left. That would happen inside the function. And again, anything that's inside the function is opposite of what you would think. So that would be x plus 4. And then the 5 units down would happen outside of the function as minus 5. It says state the domain and range of each function. So they want us to do the red one and the blue one. So domain. Now, if you're trying to find the smallest x value, be aware that when there's an arrowhead on the end of the graph, that arrowhead means that it's going up forever as well as going forever to the left. The only time it would not go forever to the left is if it was exactly perfectly straight up and down. But this is a bit of an angle, so that means it's continuing forever to the left and forever up. This arrowhead too, right? It will go forever up, but it will also go forever to the right. So with that in mind from that red graph, can you see that there is no smallest x value? Because it's going forever to the left. There is also no biggest x value, because it's going forever to the right. It has everything from the left and everything from the right. So we write that either like this. X can be any real number. That's the set notation. Or in interval notation, we say, let's start at negative infinity, because that's forever to the left. And let's go all the way to positive infinity, because that's forever to the right. When we get to the range, there is a smallest y value for the red graph. Coming up from the bottom, can you see the smallest y value is 0? But there is no biggest y value because it goes up forever. So we could write that in set notation by saying that the y values are always bigger than or equal to 0. Yes?
It says there we should only write the equation of the image graph.
Yes, it says write the equation, but it does say state domain and range of each one. So we're going to do the red one, then we'll do the blue one after. So this would be set notation, and for the red graph, the range starts at 0, but goes up forever, 0 to infinity. And we use a square bracket when we include a value, and round brackets when we don't. So now we can do the same thing for our blue graph, domain and range. Again, it's everything. I'm just going to write the set notation for the blue one. The domain is everything. Now the smallest value is -5. And it goes up forever. So the range would be greater than or equal to -5. Questions on this one? 8, 9, and 10.